is our geometry review. Let's get rid of this guy. Let's see, part 2 for test. What have we covered? 1 through 15. Okay, lessons 1 through 15, not questions 1 through 15. All right, so we're going to pick it up on part 2 with question 11. Let's see, they're going to show you a right triangle. It's going to look something like this. It's going to have a right angle here. It's going to come across. It's going to give you a right angle here. We'll call this A, B, C, and D. See what measurements they give you. They give you some complicated numbers here, like, I don't know, like 19.6 and something like 11.76. And what they want to know is, what is the perimeter of the larger triangle? This may be the hardest question on the test, in all honesty. All right, have we talked about geometric mean at all? No? Okay. Well, what we have in here is we have 3 similar right triangles, but I think, let's see if I can make this any easier than that. I'm almost tempted to take this question off because it's so difficult. Because really the measurements that we're looking for here, so we need to find this measurement, we need to find that measurement there, and we need to be able to add it to 19.6. All right, those 2 measurements. Okay. All right. Let's see. We are going to do this. We're going to break this into 3 similar right triangles. Okay. So we have 3 triangles here. We have our largest triangle, ABC. Then we have our middle-sized triangle, which is DBC. And then we have our smallest triangle, which is ABD. Can we see those 3? So I need to redraw these, and I'm going to redraw them so that they are all facing the same direction. Okay, and this may be one of the harder parts. Okay, now my larger triangle, this is my 19.6. Okay, this is C. Notice how the right angle there is at B, and then A is over here. Questions about that? Does that make sense? Can we rotate it in our heads to look like that? Okay. Now, this one here is a little bit more difficult. Notice that I have a right angle there, so that's going to be angle D. This is C. This is B. And 19.6 goes right there. Can we understand that? Okay. And then we have our small guy. So his right angle is there at D. Let's see. B is right there. Now, the part that we want to use on that small triangle is that distance of AB. Okay, and we do have one measurement here, which is 11.76. Okay, does all of that make sense? Okay. Now, like I said, all 3 of these triangles are similar, which means their corresponding sides are proportional. Okay, they're not the same length, but they are proportional. All right. Let's see. Let's do this. Do we have any common ABs? Notice how AB is going to be the same length as AB, right? So let's refer to that as X there and there. Okay, so let's look and let's see if we can solve for X. Okay, we can do CB over BD. Does that make sense? Let's see. That may not be enough. And what else do we have that carries over as the same length? Do we have any? Don't have any CAs common. Okay. BD. Notice BD right here. What is this BD the same as? Is it the same as this 11.76 here? Okay. So I can fill that in. 11.76. All right. Now that really helps me because I can go from this big triangle right here and look at it in relation to that triangle potentially right there. Okay. Actually, what we can do is we can solve for CD and get all of that triangle by doing what? Pythagorean theorem. So 11.76 plus b squared equals 19.6 squared. So this is where we need some calculator work at. One 3 okay, plus b squared equals 19.6 squared. 384.16. Okay, those have been squared, so we would subtract 138.2976 from both sides. Leaving me with b squared equals 245.8624. And then finally we'd want to square root both sides. $15.68. Okay. All right. So we've got 15.68. All right, now notice that we can set up this proportion here. We can do 19.6 over 15.68 equals 11.76 over x, and that's solving for that x right there. Okay, cross multiply. What's 15.68 times 11.76? 3968 equals 19.6x. Divide by 19.6. Divide by 19.6. 9.408 equals x. So this is 9.408. And remember, we're trying to find every length of this big triangle, correct? All right, now the last step, can I just do Pythagorean theorem here? Okay. So if we do 19.6 squared plus, what do we have, 9.408 squared should equal that c squared. We already know that, well, maybe we don't in this case. What's 19.6 squared? I thought we'd already seen that, but maybe we haven't. 184. Oh, sorry. 384.16 plus 9.408 squared. Okay. Chances are we won't need to run the decimal point out that far, but let's go ahead and add 384.16 to 88.5104. I may put this one as a bonus question, but don't count on it. Okay, what do you get? Okay. 436.
67046.
Okay, we'll stop there. Equals c squared, so we want to square root 436.67046. No, take it to like 4 decimal points.
20.8966.
Okay. You feel like our answer's wrong? 20.8966. 20.8966. So what's our last step? What do we need to do? Nope. We already have. We should have everything that we need. 19.6 plus 20 point, let's call it 20.90 plus 9.4. Add them up because we're trying to find the perimeter, right?
What did we say in the 20.89?
Let's call it 20.9. 20.9 plus 19.6 plus 9.4.
49.9.
Yeah, we're wrong. All right. If we have to, we'll come back to it. Chances are I'll take it off the test. Let me see how many questions are on the test. Yeah, there's 20 questions, so we have room to cut that one out. Okay. I'm glad we spent that time. All right, 12. But you got some good practice in there. And the truth is, because I wasn't running the calculator, I don't know if there was something that was just simply punched in wrong or what. But number 12. We've seen a couple of questions like this so far. They're counterexample questions. On a counterexample, you're basing it upon a conditional statement, right? What part do I want to, what part of the conditional statement does my counterexample need to match? No, opposite. Hypothesis, the first part. Counterexample for okay. We need a counterexample for this statement. If x is less than 10, then x squared is less than 100. What's that? 9 is less than 10, that's true. But is 9 squared less than 100? Yes, so is it a counterexample? Guys, I don't think you understand what a counterexample is. A counterexample is something that runs contrary to our statement. It proves that our statement is not necessarily true. Okay? So we're not trying to prove the statement. We're trying to find something that proves this statement is wrong. Okay? But it has to match. We have to find a value for x that is less than 10. But whenever I square it, is not less than 100, meaning it's greater than 100. Yes, you can. All right, it's a number squared. It's a number that is squared. Go backwards from there. Go backwards from 1. Negative 11 would work. Negative 11 is less than 10, correct? What's negative 11 squared? Negative 11 squared. If you don't put it in parentheses, you'll get negative 121. But negative 11 squared, if we've done it right, is greater than 100. Therefore, if x is negative 11, if x is any absolute value greater than 10 but negative, okay, it's going to have a squared version of it that's greater than 100. Does that make sense? Okay. So we could write up negative 12, negative 13, negative 14. We could come up with all kinds of counterexamples. But all my counterexamples in a question like this are going to be negative values with absolute values greater than 10. Does that make sense? Okay. 13. If all angles of a polygon, okay. Let's say this. Let's say if all sides of a polygon are congruent, how would it be classified? How do I classify a polygon when all the sides of that polygon are congruent? Equilateral. Helps if I can spell. Equilateral is correct, okay? But for sake of argument, let's say that the question was all the angles are congruent. Equiangular, okay? Okay, here's a final question. What if all the angles and all the sides of a polygon are congruent? What's the term for that? Regular.
What's the irregular?
Irregular is anything that's not regular. So it can be equilateral, but if it's not equiangular, it's irregular. Okay? The answer for this question is only equilateral. Okay? We don't have enough information to say it's equiangular. Now, if they'd said that that polygon was a triangle, then we could say, well, by definition, it's going to be equiangular, and if it's equiangular, then it's going to be regular. All equilateral triangles are all three. All equiangular triangles are all three. But it's not specific enough to say that because it just says polygon, okay? But that's good observation. Okay, 14. All right, you've seen this question on a test. So angle 1 and angle 2 are vertical. Angle 1 equals 4x plus 32. This is 10x minus 70. What is the measure for angle 1? That's an important part of the question because we're going to have a tendency to solve for what and stop. X. All right? Big hint off the beginning is what word? Vertical. Right? Vertical means what? Vertical angles are always, no, well, yes, that might be true. They're up and down from each other or side to side from each other. No, vertical angles are not parallel. Sides, lines can be parallel, angles cannot be. Congruent. Vertical angles are congruent. Okay? Vertical angles are congruent. Do we know that symbol well enough that if I write that up instead of the word congruent and we know what in the world I'm talking about? Okay. All right, so if vertical angles are congruent, then what am I doing with these two equations? Okay, so 4x plus 32 equals 10x minus 70. Solve for what? X. When I'm all done, do what? Plug it back in. All right, so what do you want to do first? Minus 10x. That's going to give me a negative x over here, which means you're going to subtract 32, and you're going to wind up with two great big negative numbers. How about we subtract 4x? and add 70. Okay, so that's going to give me 102 equals 6x. I don't know, I made up those numbers. 102 divided by 6. Does that come out? 17. X equals 17. And if this is left as a multiple choice question, 17 would be an option. I don't know if I'm going to leave it multiple choice or not, but it would be one of those answers to trip you up. You would think, hey, I'm done because 17 is one of the solutions. But what I haven't done yet is plugged it back in. All right, which is a very, very common mistake. 4 times 17 plus 32. Is it 100 degrees? I don't know. I don't know my 68 plus 32 is 100. Okay, so measure angle 1 equals 100 degrees. That should be my answer. Okay, so we know what to do with that. Vertical angles are congruent. We got 10 minutes? Okay, we killed too much time on that one question, didn't we? All right, distance formula. You got to know it because they're going to give you 2 coordinates. Okay? Okay, what is the distance formula? That is exactly right. You can flip your x1, x2s, but if you flip your x1, x2s, you have to flip your y1, y2s. Okay? So pick a way, stick with it. Okay? Don't flip-flop it on yourself. There's a lot of places to make mistakes here. For one, you might put your y's on the left, your x's on the right. You might have x2, x1, and then y1, y2, which would not be good. You might forget to square it. You might forget to subtract between those things. You might forget to add in the middle. You mess any one of those things up, you're likely to get a wrong answer. Okay? Now, if it's me, I'm going to go ahead and I'm going to write up here so that I know, okay, x1, y1, x2, y2. Okay? Because what I have seen people do is write x1, x2, y1, y2. Right? Granted, in the video, you can't see what I'm pointing to, but they'll make -8 and 3, x1 and x2. They'll make 4 and 0, y1 and y2. That'll mess it up. Okay, so x2 is what? 4 minus... No, you... -8. Okay, that's the kind of mistake we'll make if we're not careful. All right, and then whenever we come down, make sure you bring everything down. Don't forget your squares. Okay, y2 is what?
0.
Minus 3 squared. All right, what's 4 minus -8? No, positive 12, because plus 12 squared. Okay, 0 minus 3 is -3 squared. We got 144 plus 9. What do you get with 144 plus 9? 153? Yeah, 153. Now, here's the thing, is if you get an answer like that, what we need to do with it is we need to simplify it. Do we know how to simplify a radical? Can I take 153 and divide it by anything? Can I divide it by 3? All right, so we can divide it by 3 and get 51. In this case, it's probably prime, okay, because I don't think 51 divides by anything. I can't think of 51 showing up on anything. So in this particular question, right, that's as simplified as it gets, okay? But you need to test, if you get a radical and it looks like it can simplify, do we know how to do that? Some of you do. Anybody in here not know how to simplify a radical? Okay, so Garrett, give me a pretty decent sized number, like make it an even number so we know that we can simplify it. 146. Okay, so we know we can divide that by 2. We should get probably like 73, which doesn't help us go very far because 73 is prime. Let's try 156. Let's divide that by 2. What does that give me? 78. Okay, 78 divided by 2 is 36? 39. 39. 39, I think, is divisible by 13 and what, 3? Okay, because 13 and 3 won't go down any further, all I can take out is that pair of 2's because it's a square root. So I get 2 radical 39 for the simplified form of that. Does that make sense? Okay, because 13 times 3 is that 39. All right, 16. We'll just go till we run out of time. What time are you guys out of here? All right, identify a plane in the diagram. Can you guys do that? It has to be 3. If I'm identifying a plane, there's 2 things I need. And people are still making this mistake. Okay, I've got okay, is BCE 3 points that I can make a plane with? No. 3 non-collinear points. B, C, and E are in a line, which means B, C, and E cannot form a plane. BCA can form a plane. DCE can form a plane. DC or BC, DE. You can include pretty much any 2 points in F. Okay? Yeah, it's on the plane, so I mean it's on the diagram, so I can include it if I want. Okay? Now, it has to be 3 points. It can't be a ray, it can't be a line, right? It's got to be 3 points that are not in a line. Okay? 3 non-collinear points. All right. 17. All right, you're going to get one where it's talking about an angle bisector. So A, B, C. Now, they're just telling you this. They're not going to draw it for you. You need to know how to draw what it is that they're going to describe. But they tell you that BD is an angle bisector, which means it's going to divide both those segments equally. They might say, they're going to tell you what this is, and maybe it's like 12x minus 5. They're going to tell you what the other one is. They may say it's like 4x plus 14. Okay? What they're going to ask for is, they're going to ask for like this section right here. Okay, which means I'm going to set these 2 things equal to each other, solve for x, and then plug x back in. Okay? Set them equal. This is where you're listening to the video, right? Because I'm not writing this up for you. Okay? Set them equal, solve for x, plug x back in. 18.
You plug in for both equations.
No, just for ABD. It wouldn't matter because they would be the same anyway because they're equal to each other. All right. Here's the thing, guys, is that I know that there's probably 3 questions that we didn't go over, but I'm pretty sure that those 3 questions will be covered in the other set of videos. Okay? So watch all the videos. I've covered as much as I can get through. Yes? You got your review done. All right, let me hit stop on this, and then I'll take all that down.